Hello everyone. I welcome you all for my presentation. Myself Prakash, Assistant Professor from Mechanical Engineering Department, Tyagaraja College of Engineering, Madurai, Tamil Nadu. This semester I am handling the course called Geometrical Modeling for sixth semester BE Mechanical Engineering students. In this course, uh, we have five course outcome, and this is my Bloom's level. So most of the course outcomes are TPS 3. TPS stands for Tyagaraja Proficiency Scale. Normally in our institution we follow this scale. So I am going to the topic called 2D geometrical transformation in geometrical modeling. This topic covers the course outcome 4, implement the transformation and the projection over the geometrical model. Activity jigsaw. So recently I did jigsaw activity for my students. So 13th March 2020 Monday, I tried this activity. The chosen topic is 2D geometrical transformation. So it has a four integral part like translation, rotation, scaling, mirroring. The time allocated 50 minutes because I have a 50 minutes hour. So the student strength is 40 and the groups are, I created 10 home groups. Each group has a 4 member. Why I choose this topic and jigsaw? This topic naturally divides into four distinct topics, each with its own transformation matrix and effect. The four distinction topics are translation, rotation, scaling, and mirror. And the jigsaw makes every student responsible for mastering one subtopic and teaching it to the peers. So normally it is used to learn one particular topic, and it is used to learn more than one topic from the peers. The interdependence encourages deep individual preparation, promotes peer explanation, and ensures that all four transformations are understood collectively. And research shows that teaching others strengthens one's own understanding. Jigsaw leveraging this to build both content mastery and collaboration. That's why I choose Jigsaw. So my objective is very clear. The students should learn four geometrical transformations by this method. Okay, how I implement? There are four steps. The first step is I created a group. It took 5 minutes. So students sat in their pre-arrangement home groups. I gave a member a slip with the number 4. As I said earlier, each group has a 4 member. So I given the slips. So it has a 1 to 4. The students should pick any one number. They kept that number and become the expert the transformation. I explained that they would later teach to the other groups. So step two, it's a create a expert group. It took 12 minutes. So I insisted that all students with the same number move to the designated corner. So there are four corners I put. Serial number one should be the one corner, two, three, four, vice versa. And I said the translation experts in front and front left. So that is the group number one. Similarly, rotation for group two, scaling for group three, mirroring for group four. So in these expert groups, they use it to summarize and guiding questions to discuss their transformation. I circulate the answer for their doubts. Each expert took notes to bring back. So this stage, every student expert in one particular one particular topic, such as team one translation, team three scaling, etc. And then step three, reporting back to the group. It took 15 minutes. So experts return to their original home groups and they exchange their answers to the other three members using the example from the summary. So I walked around and observed that students were writing down matrices and checking each other's calculation. So after all four experts thought, each group collectively prepared one-page summary covering all the transformation. I collected the formative feedback. The step four is the evolution. So it took minimum actually 30 minutes, so for nearly 42 minutes, 37 minutes. So to save the time, I skipped the group presentation and an institute gave a short individual quizzes. It is a 5 minute with a 5 MCQ covering all the four transformation. So this held every student's accountable. I also used the group summarize to see overall understanding. So this is my implemented steps. Before implementing that, I need to prepare something. So I prepared my preparation because first previous class itself I teach four transformations, the basics of four transformation. So next day once I enter the classroom, I announced that you will become expert in one transformation and then teach to other group. We will see how much you learn by teaching. So the chosen topic study geometrical transformation. It has a four subtopics. So groups formed. I created 10 heterogeneous groups with the four members. Discussion cues. I prepared some discussion cues, and I given some examples like translation example. A point 32 is translated to 4 to 1. All those things. The time allocation, it nearly took more than 50, but I constructed for 50 minutes only. So for group formation 5, the Excel group studied the subtopic 12, return to home group 15, home group is summary 8, individual quizzes and a debriefing or wrap up. So what's my student reaction? So this is very, very important aspect. So the classroom energy was high. Students initially hesitate to leave their friends, but once in expert group, they quickly engage with the material. In the home group teaching phase, I observed active discussions. Many students wrote down examples their peer, what the peer explained. The final to score that there are some improvements. So I took pre and post assessment. Both based on the assessment, I found 80% is good. 80% we got improvements. So what worked well? The expert groups study sheets provided clear focus. Rotating roles gave every student a defined responsibility. The individual quiz held everyone accountable, reducing free riding. And what's my gaps is some expert group finished early and become distracted. So I thought I should prepare some extension questions or advanced questions. A few home groups struggled with their management during teaching, so the summary was rushed. Noise level was higher than the expected, making it hard for some students to concentrate. So modification I plan to do again. Though I felt there are some modification I need to. One is include a sponge activity expert group that finish early. So few students are finished early, so I need to give more additional practice problem. Provide a simple teaching template for home groups to keep them on track, and set clear noise expectation at the start. Use a visible timer. So overall, Jigsaw proved efficiency effective in collective area with the subdivisions. It fostered independence and gave the students a chance to be expert and being confident understanding. So this is my geotag photo. So thank you all.